Today I'll tell you about the translation. A translation is an isometry that moves a shape by sliding it up, down, sideways or diagonally without turning it or making it bigger or smaller. A translation vector can be represented by a column vector AB. Now for example, if we have this point and I want to translate it, so you can see that it's always represented by a column vector which is described here. So for example, if I want to move this point by a translation vector which is given to me 2, 3. So remember one thing, that this 2 is x and this 3 is y. And whenever we move the point by translation, we first move the x and then we move the y. This order you need to remember. So I want to move this point by a translation 2, 3. So what I need to do, first I'll go 2 step right. So from here, this red point, if I go 2 step right, I'll go 1 and 2. And then I need to move 3 step up. So 1, 2 and 3. So this is the point where I will reach. So I'll mark a point here. So for example, if this point is A, then this will be my new point, A dash. So this is how we move it. Now I'll give you one more example. If we have another translation vector, let's call this is a translation vector. This is part A. Now part B, we have another translation vector, -1, 2, and we have a point B, 1, 2. So we have this translation vector -1, 2, and we have a point B, 1, 2. We want to translate it. Translation means to move actually. So we need to move it in another location. So what I need to do, I'll mark another point B here, which is 1, 2. So from the graph you can see this is 1 and this is 2. So I'll mark the point here. So this is 1, 2 and I'm naming it as B. So now I want to move it minus, translation vector is -1, 2. So -1 and 2. So when I want to move it -1, remember one thing, that we have positive, we need to move on the right side. When we have negative, we move to on the left side. Positive y upside and negative y downside. So this translation vector is saying -1, 2. It means we need to move 1 step back and 2 step up from the position. So from this B, I'll move 1 step back here, from here till here, and 2 step up. So 1, 2. So this is the image. This is my destination point, B dash. So this is how we find the image. We have given the B object and we want to find the image by a translation vector. So this is how we do it. Now this was when we have given an object and we have given a translation vector. Now I'll tell you how to find the translation vector when we have given an object and an image. So I'll give you one more example. Now let's say we have another point C here and we have C dash also, which is lying somewhere here. And now I need to find in part C, I need to find the translation vector. I have C given, which is -2 and -2, and I have C dash given, which is 1, -4, and I want to find the translation vector here. In the question it can say that C is mapped onto C dash When they say mapped onto, it means that its transformation is happening. So if I say C is mapped onto C dash, by translation find the translation vector. So this could be the question for this. So we need to find the translation vector. So it's a very simple method which I'll tell you, a very easy way, that you will simply see the object. You know C is the object and C dash is the image. So we will start from the object and we will go to the image, and we will follow the first rule. First we will move X and then we will move Y. So from here, if I want to go to C, I'll move 1, 2, 3 step right and 1, 2 step down. So first 1, 2, 3 step right means positive 3, and then after here I need to go 2 step down, 1, 2, so minus 2. When I'm moving down, it's minus. So you see how easily you got the translation vector. If I show you through the dotted line, you can see first I move like this till here, because C was lying below it, so then I have to move it. So this was 3 steps right and this was 2 steps down. Since it was right side, I am moving right side, so positive, and down side is negative. So this is how we write the translation vector. Now what about if we don't have the graph and they give us object and image, or they give us object and translation vector? How can we find the image? So for that we have a very easy formula. Image is equals to translation plus object. So for example, if they give me that we have a point A which is 2, 3, and they tell that we have a translation vector which is -2 and 4, and then they are asking us to find the image, and the question could be that A is mapped onto A dash by a translation vector -2, 4 or -2, 4. Find the image. So we need to find the image. We know this formula which I have told you, image is translation plus object. So I'll just be applying the formula. So in place of image, I don't know the image, so I'll write I as it is, and then we have translation vector which is -2, 4, and then plus object. So object is 2, 3. Now one thing you need to remember, that this A is written in a coordinate form like 2, 3, but whenever we are solving the translation, we need to write it in a vertical form, in a column vector form. So I'll write it 2 and 3, and remember the first value is X and second is always Y. So now the image will be -2 plus 2 and 4 plus 3. So image will be 0 and 7. So you see how easily we can find. In the same way, they can also ask us that if we know the image and the object, and they can ask the translation vector. So simply you need to do the same way as I did. I'll give you one more example. If they say we have A 2, 3 and B 5, -1, and they ask us to find a translation vector. So the question could be, A is mapped onto B, find the translation vector. This is the question. A is mapped onto B by translation, find the translation vector. So again, you know the formula. I is equals to translation plus object. I is the B. Always remember, when they say A is mapped onto B, I'll write it here so you know what is actually going on. A is mapped onto B by translation, find translation vector. So you see, they are saying A is mapped onto B. So whatever is the starting one before mapped, this word map is written, or if they say A is transformed into B. So this initial one is the always object, and this B is the image which is transformed. So the original is object and the transform stuff or the move stuff is the image. So now we will use the formula. Image, we know image is B, so image is 5 minus 1. Translation vector we don't know, so I'll write T here, and object is 2 3. So here it is plus, I'll shift it to the left side, it will become minus. So 5 minus 1 will remain as it is. I'll put the minus sign and I'll shift this 2 3 to the left side. So 2 3 will remain as it is equals to T. Now I can do simple subtraction. 5 minus 2 I'll write in the bracket, and minus 1 and minus plus minus 3 is equals to T. So 5 minus 2 give us 3, and minus 1 and minus 3 give us minus 4. So we have T is equals to, we can write it in a correct order like 3 minus 4. So this is how we can translate any object when we have given a graphical method, when they ask without graph. I have taught you both the ways. Now I'll solve few questions from the past paper, so you know how and which type of questions come in the exams, so you know how to solve it. So first question is, the single transformation P maps A onto B. Describe fully this transformation P. So we need to describe the transformation here. So whenever they ask us about describing, we actually need to write that it's a reflection, rotation, translation, which transformation it is, and then accordingly we need to write the answer. So here first thing we will see, we have two triangles here. So the first rule is to join the corresponding points. So I'm joining it. You can see if I join it, these are a parallel lines. So parallel line means that it's either reflection or translation. If the image is flipped, then it is a reflection, otherwise it's a translation. So it's a translation. Now we simply need to write the translation vector. So for this you can choose any point, and they are saying A is mapped onto B, so means this A is the object and this B is the image. So from A I'll take any one point. So this 90-degree point on a triangle is easier. So now I need to go to the image, so I'm moving one step, then 2 step back. So my translation vector will be minus 2 on the x. I move 2 step back, and since I'm not moving vertically, so it will be 0. So this is how we write, and it's quite easy. Now this question, triangle T is the image of triangle Q under translation minus 2 1. Draw and label T. So we have given a Q which is an object and T is the image. It's written here, T is the image. So we have given the translation vector, we have given the object, we need to find the image. So it's also quite easy. What we will do, we'll take all the corresponding points and move according to this translation vector. So I'm taking this point for example. So the translation vector is minus 2 1. So I'll move 2 step back, 1 and 2, and then 1 step up because it's positive 1. So 1 step up from here. So this is my first point. In the same way, I'll take another point. This is my another point. Now same thing I will do. 2 step back, 1, 2 step back, and 1 step up. So I reach here. And then my third point, 2 step back. So 1, 2 step back, and 1 step up. Now I'll join all these. So this is my required triangle, and I'll remove the extra parts so you exactly know the triangle. So you see, this is the way to do it. Now the last one, we need to write the translation vector here. A is mapped onto B. So same thing we will do. A is the object. The most important thing is that we need to see what is object and what is image. I have told you whatever comes in the beginning is usually object, and whatever is mapped after is image. So from A we need to go to B. So this is the point. So first I'll move horizontally. So I have to move 1, 2 step right, and 1, 2 step, 3 step, and 4 step down, because these are the corresponding points. I am highlighting it with red color. So you see these are the corresponding points, so I have to follow this path. 1 2 step right, so I'll write 2, I move 2 points on the x, and then 1 2 3 4 down. So down means -4, up means positive, and right means positive, left means negative. So if I show you how I move, like this I move, and then I move down. So this is how you can write. See, it's quite easy. I hope you have understood the translation